Your way.
Is there like a... Thank you. That's why I was like, where is the thing?
It can be untethered.
Perfect. Okay. So our last session together about connecting children's previous knowledge, and we're going to actually engage in a fraction task today like I would want to see in a tier 1 classroom where kids are thinking about fractions. But it's going to be a problem that's challenging to us, so it's not going to be the problem you take back to your class. But it is going to be around fractions. And then we're going to kind of debrief that. They always have these slides. They're not mine. Well, we're actually not. We're going to go. I went through and looked at your implementation guides and actually took out some of the pictures, and then we'll do that stand piece and kind of reflect, because I do want us to look at the work that you put into your implementation guides this year. And then we're going to talk about, like I said, we're going to do a fractions task, and it's going to be specific around multiple representations. That's what we're going to be thinking about. And versus, who's heard of CRA as a process? CRA, so concrete representational abstract. Sometimes we call it build it, draw it, write it. And we're going to kind of compare those two and talk about what is multiple representations versus the CRA, and why would we want to talk about multiple representations. And then we're just going to have a reflection at the end. So I did go through your implementation plans and just wanted to celebrate a lot of the things that you guys were doing. So several people had used that test that we had talked about in that first session, or I think it was the first session that we did it, and just looked at that to see where are kids at in my class and how can I respond to them. And you looked at them in very different ways, and you saw different results, and you responded in different ways, but it was really encouraging to just see how zoned in on student work you were, and trying to think about what kids did understand and what they needed to do next. I loved all the pictures. I'm just going to give you a minute to browse. So thinking around kids creating the models this year instead of using those kind of pre-partitioned models, or thinking about models that weren't actually accurate. We always put models in front of kids that represent the 2/3 and they're already partitioned. So lots of work happening, letting kids create the models and really wrestle with equal parts and how many parts to draw. Some more pictures. Lots of uses of the games and activities that we gave out in the first couple sessions. Some people even were able to purchase Cuisenaire rods. You didn't need them, but they really liked the idea of the Cuisenaire rods.
My school had stashed them all away.
Yeah.
And I went and took all of them.
Yes, nice. I have found that.
Thrown out.
Yeah, please. Somebody's got them in their closet, right? And some people don't even know what they are anymore because it's been so long since we've used them. So over and over again in the implementation plans, the use of manipulatives and activities came up. Cuisenaire rods, fraction strips, and letting kids really experiment. Thinking about how to make more tasks open for kids' understanding. So there was one particular one that talked about students debating each other about an answer, and that was just really powerful. Thinking about student understanding, that was really relevant when you looked at the assessment data, more than just correct answers. Someone noted that one-on-one interviews provides insight into student thinking that is not visible in written work. And so I want to kind of piggyback on that sometimes we don't have to interview every one of our students to get insight into how students think. We can choose 3 or 4 students and sit down with them and talk with them and confer with them, just like we do in literacy. And then we can design interventions for our entire class, or design instruction for our entire class, just based on what they say. Experiences that students revisit to build on previous understandings. Surfacing of misconceptions to build new connections. There was a lot of surprises about what kids did believe about fractions versus what we thought they believed about fractions. Lots of celebration around students defending models and explaining their thinking and how they were becoming more comfortable with that. And then iteration was named specifically. It was just a new way to think. There are also challenges, always challenges, right? When there aren't any challenges, we should retire because we've arrived, and it's the perfect way, that year is our perfect year, and we should just go out on it. But it is hard to get kids to transfer knowledge to new scenarios. And I would argue that if kids are not transferring that knowledge, then they don't have that knowledge. That knowledge is setting specific. It was specific to that task or that activity, and they haven't generalized that experience. And so that is tough. Generalization is not an easy part of mathematics. If you think about your standards for mathematical practice, the last two are really about generalization, right? Noticing those patterns and then describing those patterns of repeated reasoning. It is the ending, right? The capstone of it, and it is very, very difficult. In our standards, the standards actually have trajectories. They don't happen in 1 year. We don't develop multiplication in 1 year in the standard. So the generalization, sometimes, depending on your grade level, you're just starting the exploring. And so it will be setting specific. And that's really tough because we have assessments that maybe don't let us explore as much as we want to, and we have to acknowledge those constraints in our job as well. And that kind of goes to teaching to the test. I want to explore, yet I have these accountability measures, and we have to acknowledge that that's a challenge and a constraint. Time, of course, always. Deeply rooted misconceptions of fractions and tackling that, which will end up becoming deeply rooted misconceptions that affect them all the way through mathematics. Students having procedural knowledge, I've said this from the beginning, that it's much harder to intervene with 7th and 8th graders than it is with 3rd and 4th graders, because they have really set procedures and they have misconceptions about those procedures, yet they don't want to engage again in that concept because they've already learned that concept, yet they haven't learned that concept, and it is really challenging. And then transfer from concrete representations to procedural and how to do that. And I think really that relates back to that transfer to new scenarios. Once again, kids do really well in hands-on activities. They notice patterns, but the generalization, just because kids notice patterns and can draw things doesn't mean they can generalize the concept. And that's a huge challenge for mathematics educators, how to get to that generalization. So let's go back to their slide, which I think is a good way. Close your eyes if you get sick. And I want you to think about what's one success that you've been able to record in your implementation guides. If you haven't been able to record it, think about what is one success that you have had this year, not around problem strings, but around fractions. So it can be about anything. I mean, anything that you've learned at MichME. It doesn't have to be specific to fractions. And then if we can actually join groups, I'm not going to make you stand up and say this to the whole group, but if we could make 2 tables of 4, and then just let's actually share out round table with everyone. So what's a success that you've had from your learning this year at MichME? Would you guys be, and then if you guys would come up here, to move your stuff, just if you want to just quickly join. If you want to move, you're welcome to as well. Comments. I want you to think about, even if you haven't heard this phrase, I want you to think about this idea. This is really common for people who work with students in intervention. We hear all the time, oh, you have to work through the process, concrete, representational, abstract. And so I want you to think about that. What does this commonly cited phrase mean to you? In what ways might it or has it been useful to your thinking about teaching and learning math? And what might be its limitations for you? So I think there are some useful things about this phrase, but I think there are some limitations too. So that's what I want you guys were already kind of starting to talk about representation, so start to talk about that specific flow, concrete, pictorial, abstract, concrete, representational, abstract. I'm going to give you maybe like 3 minutes to talk about that.
By the time we're For a lot of kids, or they want let's have some time with why don't you just tell me what 3 steps to do instead of going back and trying to. That's the hard part.
But it was just,
getting them
with
to
little manipulations, it wasn't like.
motivated enough to go back and figure out how. They just want to kick hard around and don't want to figure out how the engine works.
Not use all the stuff. Sometimes when they're doing the concrete, they'll come up with other stuff on their own. And that, then they remember it a lot better if they did it instead of you telling them like how to do it. Other ones, yeah, so.
So I've heard from both tables that the concrete is a really important experience for kids to have and make connections to. And that sometimes it's lacking for kids. I also heard that that when you start with the concrete as the starting point, that often the other 2 pieces naturally come out. So that's ways that it's been useful to you. What are some limitations, do you think, of this? Let's just talk together about that. Yeah, say that louder.
Sometimes they never get there.
Yeah, so there might be, if we think about this as a process, we might think they never get to the abstract. So we always stay in one place.
And if you're leaving the concrete behind, then as the abstract gets more abstract, they don't make the connections between concepts.
Yeah.
I mean, I'm noticing in subtracting mixed numbers, my kids don't have concrete knowledge in subtracting whole numbers.
Ah.
So when they regroup with the fractions and everyone wants to convert to an improper fraction and then subtract. No, you don't have to do that. You
Yeah.
can regroup just like you can in whole numbers, but they don't understand how to regroup with whole numbers.
Yeah. So they're building on procedural knowledge as opposed to this conceptual, like what does it mean to regroup? Other limitations?
And my question always is, because I do a lot of intervention stuff, when do you move on? How long do you let them get caught up in that?
Yeah. So this is actually from Susan Jo Russell, who's done a lot of work with elementary students, K6-ish, in thinking about arithmetic to algebra. And her research is really around how to get kids to think about complex things, young kids to think about proving things. And that seems like way out of the box, right? Like, no, proofs start in high school. But she's actually done a lot of work in urban districts around the country with working with students and getting them to algebraic thinking in early grades. Not using letters or anything like that, but the process of proving and the habits of mind that we need students to have to be successful in higher levels of math. And so she says that what's useful is it does highlight the importance of models. And you guys were definitely talking about the experience that you have with a concrete object, right, is really important. Some kids come to us with experiences from home and some kids come to us without those experiences. So having those common experiences is really important. It also helps them to develop images, right, to link back to, this is what it means to regroup in whole numbers. So what am I imagining? Like I have another way other than remembering the procedure. So if I've forgotten the procedure, what can I remember? And I always think about this as I was a good memorizer, but I never really understood things. And when I learned about the unit circle and sine, cosine, and tangent, I learned an acronym, right? But I had no idea what it meant. And when I finally learned that sine was a vertical distance, I was like, oh, now I know why the graph goes like this, because it's going around a circle and the vertical distance is going up and down. Like it was this big aha moment. And I had memorized all these different units of things, of trigonometry, and no one had ever said that to me or let me play with a circle and talk about the vertical distance as like a straw went up and down. And it was like I was really angry when I found that out. I was like, I really needed to know this. So when we do think about this, it does emphasize that abstractions can, like you guys said, when they start to play it, they think they've discovered it because they discover a really interesting relationship. And they can generalize that to multiple models and contexts and images. So we can take what we've learned about whole numbers and regrouping and bring it into fractions. And that's a really important part of their thinking and experience. This comes from a blog, and I put the blog down there, but if you Google, CRA, this actually is what they say about it. I'm not going to read it. I'm going to let you read what they say. Red was my emphasis, just to be really transparent. So this is telling you what CRA is from a research perspective. So some of the limitations of it. It's defined as stages, right? Like the first thing that you guys notice with the multiple representations is there's not a starting point. Can concrete representations be a starting point? Absolutely. They don't have to be the only starting point though. And it's a limiting perspective that you have to master the concrete before you can draw the picture, before you can, and I think someone over here said, they want to skip the picture. Yeah, because at some point, I don't need the picture. I've developed a mental image. So don't make me draw something that I can imagine in my head. That's when you know they've made that connection, right? But visualization and promoting visualization of mathematics is how mathematicians think about mathematics. So how are we promoting a habit of mind? When we think about it in this order, kids want to get to the abstract, right? Because they think that's the end goal. When we promote multiple representations, we're saying that's not the end goal. The end goal is being able to represent it in all these different ways. That's when I really know you understand this. So if we take it as stages, we give a really bad misconception about what it means to do mathematics, that it's only in the abstract. And that's not what mathematics is as a body of knowledge at all. So abstract being defined as just symbolization, writing an equation. And I get it, like, right, all of our tests emphasize this, and this is what school mathematics has been about, yet that's not what mathematics as a community is about. And we talk all the time about making kids writers and who are you as a writer. We should be thinking about what does it mean to be a mathematician and what is that experience like? Will you become a mathematician? Maybe, maybe not. But the habits of mind that mathematicians have are what we want to teach you about the discipline. And you guys named, right? Tara, you said, when do they get to the end? Some kids don't get to the end because we think about it as a 1, 2, 3. If you're still at 1, you got to be at 1. You can't get to 3. So I want us, and this is just some of her research here. I'll let you read what she wrote. But I personally, with my own children, was amazed at very young ages about predictions that they would make in storybooks, when we were playing puzzles. I mean, the things that they would say, which weren't always right, but had meaning behind them and why they would predict it, right? And we don't want to say that kids can't think abstractly when they're making predictions at a very young age. But I want us to focus on connection is what is key. And that's what our story or our experience today is going to be about, is connecting these images, connecting these representations and seeing what does that tell us about mathematics. I'm not going to promise that this is going to be an easy experience. I will tell you that this fraction problem for me was really challenging. Like I sat down and I don't want it to like scare you either, right? Like, oh my gosh. But fractions are really complex ideas. And for us to wrestle with them, I think, is really important. So that's what I want you to encourage. It was also a really fascinating problem for me, too. So we are going to think about using multiple representations with a fraction problem. And I just want to give you an example. So this is the problem we're going to be doing. 4/3 times 11/9 is 44/27. And I'm going to ask you to not write this on paper. You're going to see that there are 3 boards around. And in a minute, I'm going to disperse you to those 3 boards. And you're going to work on those whiteboards. And at the end, if you want to take pictures, you can. So at the end, I'm not telling you what your product has to be, but I want some sort of justification of why is 4/3 times 11/9 44/27. And I want you to use more than one representation to prove it to me. So here's my example. 1/3 times 4/5 is 4/15. I know that's the answer because I know the procedure. By the way, I'm telling you the answer to this, so I'm not asking you. You can write it in a mixed number if you want to. I don't really care. But we know that's the answer. We all know the procedure. And so what we're asking is, let's dig into these other representations and what does it tell us about those calculations? What do we learn about it? What do we think about? What important fraction concepts do we have to think about to be able to represent those things? I'm not going to go through each one of those. I'll leave those up on the board if you want me to, so that will help you guide you. I don't care where you start even. I will say that I definitely started with the visual. You can use a number line, you can use a fraction strip, you can use a circle. Good luck using a circle, but I would really like to see that one. So you can use whatever model you want to use. I'm not limiting you in any way, but what I want you to try and explain is why is 4/3 times 11/9 44/27. What questions do you have about your job?
We just would have gone by that.
It's challenging to ask people to not work on their own paper, and so I would actually have you follow up with some personal tasks where you could do this, right? So thinking and working in a group, and sometimes we have those pieces, like, oh, I can do this piece, but then I forgot this piece, and I can go back and collaborate. So the research that I was using today is called Thinking Classrooms, and I will bring up the website so you can see it. His name is Peter, I'm going to say Liddell, but that is not, it's Swedish, and I can't say it. And he did research in math classrooms, in high school math classrooms, and he really did go into high school math classrooms and say, okay, what's the common denominator among all of these classrooms and these observations? And research is going to take too long in these classrooms to control for too many variables. So let's take these things that we've observed, and then let's do the exact opposite and just see if things improve. That is exactly what he did. So he came up with these 14 things that you can do in a classroom. One of them is to work on vertical non-permanent spaces. And so the interesting thing is, and I was trying to find a space for you guys to put your board up, but there is brain research about standing and having the blood go down as opposed to this way, and that it clears a pathway for thinking more. So obviously you'd have to be mindful of that. You don't want to stand for hours and hours and hours of time, but when you're really engaged in a rich task, that standing at a board with a group of 3 specifically, not 4, not 5, 3, because it's this. Sometimes pairs get stuck. You guys were at a disadvantage. You only had 2. But really 3 is this kind of magic number of thinking, and then standing helps as well. Vertical non-permanent, whiteboards obviously, but teachers are super creative, right? You put shower curtains on your walls and you write on them, you write on windows. So it doesn't have to be a whiteboard. It can be any surface that's erasable, because you feel much more free to just write. Yeah, and kids, adults, everybody feels that. So his research was really about putting rich tasks in front of kids and not really about content, although ours was about content. And he has lots of interesting problems and training us. So he said, our job as teachers is not to find the most interesting problem to engage kids. So it's not about engaging tasks. It's about engaging habits of mind and teaching kids habits of mind, of thinking, and those patterns. And when you learn those patterns, you bring those patterns back to your own work. And so you guys already have those patterns as educators, so I can give you a task like this. This is not a task I would give 5th graders, even though they've learned how to multiply fractions, before I've given them less intimidating tasks. Like, draw a picture of this. What are you talking about? Right? But once you spend some time doing this process with them, and really engaging in these rich tasks. And it's not about an answer. You guys talked about 2 wholes. You talked about, finding those pieces and how to partition those up. Those were those were my baseline. Like, everybody has to talk about that. And then I had some challenges beyond that. Like, can you generalize this? Can you go further? And you all got there, actually. You guys solved this way faster than I did. I mean, literally. So, could you go further with this and talk about those equivalent parts and how to partition them up? But that was an extension. Talking about the context was an extension, because the truth is, nowhere in our world do these numbers make sense in a context, right? The way in which, although the numbers themselves would work, you could take a piece of yarn that's 11/9 of a yard and make it 4/3 times bigger. But why would you want to know that ahead of time, right? It doesn't make sense as a context. But the process, the generalization does make sense for us, And so as educators, I knew you could do that, but I would engage kids in different tasks that were more interesting. And it wasn't about everybody getting to the same place. You guys took totally different paths. You asked different questions, yet you still came to those really important concepts. And so conversations, academic conversations, isn't always about the one funnel, right? To this thing. Here's the things I want you to come to, and then you can get further. So it allows kids to accelerate if they can accelerate. It allows kids to become a part of a group and add on thinking, because just because I'm, a 7th grade teacher doesn't mean someone else can't helped me. And in fact, the person who helped me think through this problem is a K-2 teacher, right? I'm a high school teacher, and I was stuck, and she was like, well, I think you're thinking about this. And I was like, you're right, I am. I'm getting stuck on this hole. And so just by having that conversation and thinking aloud. So there's 14 things that he says to bring into a mathematics classroom. And I honestly had never done it, and I thought I would try it. I've never had people stand up and solve problems like this and interact, and it really did work. But thinking about teaching kids habits of mind, of thinking, but really specifically around going deep with those multiple representations as well. You had to think about different things, even though you knew the answer was this. Like, you knew the answer was this. All of you could have drawn a number line and counted out 44 marks and labeled it 44 27ths, but none of you did that. None of you did that. You were really thinking about the 44 27ths came last on every one of your boards. Someone could have done that, and then I would have asked them, so where's 4/3? How would you figure where that was? So I'm prepared for that question, but just that like difference in thinking. All right, so you are welcome to sit down and take pictures if you want to. Yeah. They make it easy for me to travel with. I do want to bring his name is Peter, and I'm not going to spell his last name because I don't know how, but I would Google thinking classrooms. And just to show you, it's called, you want his actual website, Peter, I told you, Liddell, I think. I'm sure I'm missing an enunciation somewhere. And on his website, he actually has good problems, which is really fun, that they've done with different kids, and they even have some grade levels on them. So you could think about what problems would be interesting for my kids. I think as you think about building norms at the beginning of the year, as you think about building routines for kids to communicate with each other, these are great problems because you're not worried about the content, although content's going to come out of it. You're really worried, you're thinking about how did you guys work that out when you were stuck? Like, how did you work together? How did you negotiate who got to write and who didn't get to write? Because you guys negotiated that really well. But you're going to have to work on that with your kids, like who takes the marker and who does the talking. And at the board, some people were more vocal, and so how do we bring other people's voices in? And really training those up so that then as they go into solving other problems, they have these habits of mind. So he has lots of different things on here, but I wanted to show you guys that to explore for yourselves. So I have 4 quotes, and I want you to identify with one of those. So based on what we did today, I want you to read those and think about which quote is resonating with you. Mm-hmm. Yeah, and specifically responding to that, I forgot to say one of the 14 things is that the groups that he makes are random, and they're always random. So they don't work in the same group. So every time they work in a group, it is a completely different group. That is not for all the work that happens in the classroom. That's not what he's advocating for. When they're doing these rich tasks on boards, they pick problems that everyone can enter into, everyone can have a part in, but they're challenging enough. It's not just like if you have had a lot of experience in math, you're going to answer this question and, goodbye. Nobody else can think about it. So, what else? Yeah, thanks.
The green one, constructing.
And we're going to move on to our last part is when you guys were at your boards, your identities were very different and changing as you were working through the boards. Maybe being intimidated by the problem. I certainly know I've been in situations where I come to a board, and so I'm just going to call it, you said, I'm 4th grade knowledge. I will tell you how many times I've come to a board where I'm supposed to have the high school knowledge, right? And I'm like, oh my gosh, there's so much pressure to have knowledge that I might not have. And you start solving these problems and other people are saying things, and I feel even more pressure because I didn't come up with that. And I'm supposed to know all this stuff, but I don't know everything about math. I just know how to break problems down and think about them and seek help when I don't know the answers, right? Like that. That's really what it means to have those habits of mind. And so those identities started to shift as you guys got into the problems and started to talk, because everybody will come to the boards with a specific identity. And this community piece and, this, being intrigued kind of piece, using these representations helps us to take on new identities in math and say, oh, I am a doer of math because she left and I'm explaining what she did and now I can do this. And this was the most important part for me to remember, right? Like that is an identity in itself that kids so don't experience in mathematics, school mathematics, the way that our curriculum materials put in front of them. And that is a really important part of what we do in mathematics education is create these identities because I think like you said it best, who uses high school math in the real world? I mean, I have never solved a quadratic equation in my real life. I haven't. I know how to solve it, and I know it could be useful, but the truth is the world is much messier than that. And unless you go into engineering and things, that's not what it's about. It's about the habits of mind that we develop in kids, which is what businesses are saying, right? Kids need to come thinking to us. Kids need to be able to work in groups. Kids need to be able to take something apart and say, I don't know everything, but I know this part. Do you know a part? Because it's not about, and unfortunately in school, everybody's getting to the same part, right? That's how we're measuring them. And it's unfortunate, and I get that. But as teachers and as educators, we can say, yeah, we know we're measured by that, and we can do better things for them and know that, man, I'm not a visualizer. And so I really struggle with the visual diagrams, yet when I get them, it makes me understand things more. And so I'm gonna gravitate towards people who have that strength so that they can be on my team and that they can help me with that. But these are the things I'm really good at, right? That's what we need kids to know about themselves because that's what's gonna make them successful. I'm on my soapbox, I know. Okay. But exciting to see it actually come out in your board. So I do want you to do one last kind of reflection with someone around you. How did what you experience at your boards, really thinking about this, differ from concrete representational abstract? Because that's really the final thing I want us to think about. How is what you did at your boards different than concrete representational abstract? And find a partner to talk about. We've done a lot of reflecting. I think just for a little feedback that I could give to the group, and I know you guys are going to fill out a survey. Thinking about the 5 days, I was not a part of the mornings, but I know Rusty and Andrew and Marcus plan amazing things. So what were some things, if you guys would be willing to share, that have impacted your thinking throughout all of MichME? Because as they plan for next year, what are things that they want to make sure are still a part of those days, I guess? And then, like, as you're when you go back to your buildings, whether you're an instructional leader or not, right, what do you think needs to be in place in order to leverage kind of moving forward in practice? So any insights, everyone does not have to answer, but if you could share any insights.
I think what you've been teaching has been really good.
Okay.
We're able to go back and teach it ourselves.
Mm-hmm.
Instead of just talk. And, then you have to, okay, what did they say? How do we do that?
So kind of like the spread outness of it and then coming back. Okay.
I want more people to come. Like I kind of feel like I'm on an island and I'm pushing for more representations and everyone's just quick, like the multiplication thing. It's so easy to just say, oh, multiply across. All right, moving on to the next thing. That people do that and people that I know really well and respect very much do that.
Yeah.
It's hard for me to make a case all by myself. So
You need a community.
yes, I was saying this morning I need an army. I want to build an army to, attack the status quo.
Yeah.
So more people. I don't know how to pull more people in.
I agree. I think that administrators should be involved as well, because I feel the same way, like I'm hitting a brick wall.
I've been, kind of reprimanded for using some of the strategies. We were doing, there was last time in the morning, I think it was, they did a round robin kind of thing where everyone in the class was expected to share what they noticed, even if it was repeating somebody else's noticing. or noticing or wondering. And I did that in a science lesson, and she said it took way too much time and the kids were bored, and they weren't bored. But in her perception, because it took 15 minutes to get through the entire class, and I was revoicing and stating what they had said, it took a lot of time from my lesson. And I said, but teaching is also about teaching them to communicate too. And we had a pretty long discussion about that. So I don't know, it just makes me worried a little bit.
For sure. Administrative support is, you can't do it. You can't move forward in your practice if they don't believe in what you're moving forward in.
Well, and I think a lot of it too is the going back to standardized tests. I mean, the kids got to know the procedural stuff, but it doesn't matter if they can figure it. I mean, because you don't have to prove it. And I think that's maybe why they're pushing so hard, because
there's a lot of pressure.
There's pressure. You got to make the grade, or else you lose funding, or you lose this, you lose that.
Yeah.
So many of my poor kiddos were asking for their fraction strips on standardized tests this year. It made me so sad. Like, you want to use them, you really want to,
yeah,
but you can't.
Draw.
That's what I said. You can't draw.
You just have
the other thing that's helpful for me, I don't think we need this. So next year, the math team here did they tell you they're going to be using this book called Taking Action? So multiple representations are a part of that, and rich tasks. But rich tasks definitely in the same way, but not the Peter Liddell stand-up kind of rich tasks. But the same idea, like enough that everybody can enter into that task. So I am thinking about facilitating one of the sessions again. So I guess my question to you is, what was helpful in this session particularly, and what would you wish for in a session next year? So as we think about planning, and I can share that with the team, what was helpful, what did you wish for? If you're willing to share it, yeah.
Yeah, what was helpful about a lot of the session was stuff that we could almost like take it and then the next day bring it into my teaching, and it was something I could use right then and there.
Good.
And that, compared to the morning was very reflective and abstract, and it was nice to reflect, but there wasn't a whole lot from the mornings that I could grab right away and use, and I really appreciated the tool belt.
Okay.
That I gained.
So making sure something, I can take it away and I can try it. I can try a vertical non-perpendicular surface tomorrow if I wanted to.
Yeah, and that you gave us all of the examples to use, like concrete things to use right away. Like, we have colleagues in other classes who are not getting any of that, and they're like, oh my gosh, I wish it was a different class. I'm not going to be able to use any of this.
Okay.
So that was really nice to be. And not only when you gave it to us was it there, but it was also easy to manipulate to different grade levels.
Okay.
Which was helpful for me as being in the different grade level classes.
Thank you.
Doing things, actually getting up and doing it, not just watching it being done, but actually being put in that situation
Good.
and learning that.
Nice.
One of the things I asked for on the morning survey thing was resources. It's nice to know how we're supposed to go about teaching, but then, I feel like I'm left between really supplementing everyday math and trying to pull things on my own, or recreating and doing my own thing, both of which are so hard. And so
very hard.
Having a place to go for resources
Okay.
that's what this became, is being able to take resources back.
Okay.
It'd be nice to be able to do that in the morning too.
Yeah.
Good. It's good to hear. Anything you wished for from my sessions that I could have done better or helped you with that? I can take it. I'm always looking to improve. So what can I do better?